I really like this one. It's so many takeaways from this. It's simple and hard at the same time. That's what I like about this, and it's very realistic.
So yeah, let's look at this one. So this one is actually pretty classic login. Logins are implemented in so many different ways. This one, is a database. You have a table of users, and you can log in. And the challenge actually gives you a username and password to log in with. However, the challenge here calls you to try to log in as an admin with not having the password or user of an admin. You don't know who the admin even is. And what you need to do is log in as an admin. So the way to actually work with that is using Postman, because there's no way to use that here. So what I've done here in this example, I was using Isaac and the right password here, but I added as a SQL injection here, I closed the quote and added union all select star from users where 1 = 1. So that kind of like anything. Okay. So what I'm trying to do here is I'm getting the list of users, hitting run, and exactly what I'm getting here. As you can see, I get Isaac's the first one. Then I get, I get another one because it's a union, so I get the one that I need and the other one. Then Nikki, who happens to be the admin, because I'm trying to log in as an admin. Nikola Tesla is the second user here, and that's the admin. That's what I need. But I'm not able to log in because I have a hashed password here, right? You can see a bunch of other users that are less interesting. But in order to actually do it and capture the flag, I need to log in as Nikki, and I have it as a hashed password. So that's where I'm using an online service. There are multiple ways to do the same thing. If you watch our videos, our videos actually instruct on different ways on how to do that. But one way that I selected here is to use the crack station. So what I want to do is I want to take Nikki's hashed password here, okay? And crack station will help me because there are lists that were stocked up in the course of many, many years of MD5s and translation. So what I can do here is I can use my MD5, hit crack, and boom, I got the password. So Nikki's password is S101101, right? So all I need to do next, right, is to go here, go to the same service, okay? And now I have Nikki, I have the value, I hit send, and that's how I log in, right? So if I take that right here and I use it in our system, I capture the flag. That's it.
Cool. So why the reason that I like this is for people that are hackers, security researchers, they know those techniques. So for them, that's why I said it's hard and easy. For them, it's probably easy. They go in, do they do the SQL injection, they see the hashed password, they crack it, they go in, like basics.
Mhm.
What we've seen that when it comes to developers, because they don't think like a hacker, right, they sometimes assume that, oh, it's hashed, so it's okay.
Right.
Or it's not my responsibility that they use the simple password. I've secured it, by using a hash. So from a developer's perspective, I did add the security measures. It's really, the user is the problem, sort of like blaming the other side. However, when you write secure code, you want to write it so it will basically work for any type of users, right?
So from a major takeaway perspective, obviously SQL injection is something that I bet every developer knows about. But do we really understand how to protect ourselves from it? So the three big ideas here to prevent SQLI is to use ORM or prepared statements, prepared queries, sometimes they're called as well, or stored procedures that are well written. Those are the three best ways to avoid SQL injection. And this developer here was trying to make up an idea to maybe it's too much. We can't think about everything as developers. We need to use best practices, and that's the best practice here. Second item here is always enforce password length. Complexity is less important. You will see in our videos that you know recent recent studies show that complexity is not very important. It's actually problematic in some cases, but the important thing is more the password length. Okay, so if you're looking at password length, you need to enforce certain length that will make it very hard for people, for anyone to parse. And also there are stronger hashing algorithms like bipcrypt with some salt that actually jumps between values, and is very important to use a better algorithm that exists out there, that you can say, okay, the odds that you're going to have rainbow tables that covers those, very, very, very low, at this point at least. We're not talking about the future, but right now those are stronger, so they're much preferred. And lastly, I think this is more a high level general recommendation or an insight, which you always need to remember, guys, which is vulnerabilities are not a single here and there. Sometimes attackers, what they look for is the vulnerability to kind of like get in and then find another vulnerability to use and another to use. In this case, it's a nice demonstration of, yes, there's a SQL injection, but I can't achieve my task with it. It's not enough. I need to find another vulnerability. In this case, it was cryptographic failure or weak cipher, and this is what I found. But attackers will definitely always try to find ways. So what's the recommendation here? So the recommendation here is create multiple layers of defense. Okay, if there's a single point of failure, it will fail. People will find ways around it. However, if you put layers and layers of protection, you're decreasing the odds that someone will find ways around it. You're making it harder and harder and harder for attackers to find ways in. So always think about multiple ways to protect from different angles.